And welcome back, ladies and gentlemen, for lesson 2-9, chapter 2, section 9, solving multiplication equations. I'm going to very briefly show you the answers for assignment number 11. Hopefully you are already able to check a previous day, but just in case, why don't you go ahead, check your answers now, pause when you need to come back, come on back. And so our focus for the day, let's think about where we've been, adding and subtracting whole numbers, fractions, decimals, multiplying decimals. We've done division of decimals as well. Where are we today? Today's objective, I will use algebra to solve one-step equations. Problems like 4x equals 52, or 3/10 of a w is equal to 78 and 6/10. Then we go ahead, I want you to know where we're heading. Yes, that might seem simple to some of you, but we will eventually get to two-step equations where there are multiple numbers on one side of the equation, or multi-step equations where there might be multiple variables as well as multiple numbers on both sides. But we'll build you up one step at a time. Now go ahead and write name, date, period. Page 49, 13 to 24 all, and 33 to 41 all. Assignment number 12, solve multi-step equations. Pause, and when you're ready to come back, come on back. Now listen, we've already learned how to model equations, right? So let's say this teddy bear and 5 baseballs is the same weight, precisely exactly the same as 7 baseballs. We've learned how to write equations. We've learned how to use inverse operations. You can go ahead and cross off the 5 and the -5. You've learned how to solve and then to check, but not everything in life is addition. What about this one? I want you to think how you would model an equation for 2x's equals 8. Now let's just say an x is one of these blue blocks and one soup can, that'll count for 1. So if I were to put 2 x's on the left side, remember it's not just one, it's 2 different x's, and that's equal to 8 cans. Now from there, we should be able to figure out using our number sense how many cans would be the same as a single block. In this case, it would naturally be 4 cans. You can think about it like that. So that is how you would model an equation with multiple variables on one side. Let's go ahead on to the next one. How could we set up this? We're going to write an equation. We're going to solve for x. So 3 packs of M&Ms, $6. How much will one cost? So I'm going to go ahead. I'm going to put 1, 2, 3 packages of M&Ms, and then of course $6. I want you to think about this. How would we write the equation? Well, if x is a pack of M&Ms, then we have 3 x's. You may write the dot, but you don't have to. And that is precisely the same as $6. So here's the equation. 3x is equal to 6. But we want to know what 1x is. So with your number sense, simply split it up. Assign $2 each package of M&Ms. Now that's what happens when we draw a model, but we eventually want to be able to work that out without drawing. So how can we show division? Think about it. How can we show solving this equation without drawing a model? If our goal is b, we're going to take 5b's equals 35, and we're going to, what did we just do? We split it up into 5 parts. Now notice we put the inverse operation on both sides. If you were to split $5 or 5 M&M packages into 5 parts, what is 5 divided by 5? Well, it's a single package. Now, I'm not going to ask you to write a 1, but you're always welcome to do so. Meanwhile, 35 split into 5 parts. This must be a jumbo package because this package would be $5. So notice, please, the division bar. We're not going to use this old school division symbol. It's time to get on to middle school, high school stuff. So let's use the division bar to show or stand for division. Let's go ahead and do a few examples, please. 3 n's are equal to 39, but I want to know what a single n is. So we're going to take 3 n's and split it into 3 parts. And naturally, we're going to take 39 and split it into 3 parts. So imagine the M&Ms or the blocks. Imagine the soup cans or the dollar bills. When we split 3 packages into 3 parts, we get a single package. Eventually, I'm going to stop writing that 1. If you were to split 39 into 3 parts, you're going to get 13. And check this out. We think we know the answer, but are we really sure? Let's go ahead and rewrite the equation. 3 times some missing amount equals 39, but we think we know what this missing amount is. We think it's 13. Put a little question mark above here. You guys know me. Oftentimes, I will even cross this off or cover it up with my finger. 3 13s is 39. And when I look at this, some of us write true and some of us write check. But either way you look at it, it is a true statement. Let's take a look at the next example. 4t is equal to 64. But I don't want to know what 4 packages are. I want to know what a single package is. So let's take those 4t's, split it up into 4 parts, and let's be fair, split up the $64 into 4 parts. Now, if we do this, that's going to give me 1 package or 1 envelope of money. And if we split 64 into 4, let's see here. Let's think about this, and let me make a mistake to show you what's wrong. If I go back to check my work and I substitute in 15, now remember, I'm covering the 64 up, right? So I go off to the side and I do 4 10s is 40, 4 5s is 20. Put those together and I say, wait a second. How is that possible? That is not a true statement. So I wanted to show you an example of why that checking is so crucial. If you make a mistake, you can catch yourself, you can find that mistake, and then you can check it just to verify that you really have fixed it. So I'm going to substitute in 16, little question mark. 4 10s is 40, 4 6s is 24. Put those together. Aha! Now that will make a true statement. Please notice, as we've talked about in the past, we have the original problem, we have our algebra steps for our work, we have our solution or answer, and yes, ladies and gents, we do need to show that checking part. Moving right along, let's do a few more examples where 2Bs equals $4.80, but I just want to know what a single wallet is. So let's take these 2Bs, let's take this $4.80 and split it up into 2 groups. After all, that'll give me 1 group. I'm not going to write the 1 down. And you can go off to the side, but I think we can work this out mentally. 48 split into 2 parts is 24. 4 8/10 split into 2 parts would be 2 4/10. And we go ahead and we rewrite it, checking to see if we have the correct answer. Let's substitute in. We think we know what this missing piece is, but let's go ahead and find out. Now, 2 2s is 4. 2 4/10 is 8/10. So if I were to multiply those out, we get 4 8/10 equals 4 8/10. Looks like a true statement to me. One more example here where we don't want to know what a part of a package is. Think about this. If this were an envelope full of money equals $4.20. But right now we only have a tiny little portion. So let's split all those up. Let's take this and split it up into sizes of dimes, really is what we're doing. So in this case, what is 1/10 divided by 1/10? Again, it cancels out. You may put the 1, but I wouldn't expect you to. In fact, I'm going to stop writing it, but you're welcome to put it. Now don't forget, please, whenever we divide by decimals, let's change the divisor to a whole number. As long as we are fair to the numerator, we multiply numerator and denominator by 10. Really what this is 42 divided by 1. Oh, snap, that's just 42. And to check it, we'll go ahead and rewrite the equation. But now we believe we know what this number is, so we're going to substitute in 42 wholes. And if I do 42 times 1, it's 42, but we have 1 decimal place here. And this looks like a true statement. Now let's crank it up a notch, folks. Let's go from just problems where you're given an equation to a real world kind of problem and see if we can write it. Hot air balloon flew at 10 miles per hour using the variable h. Write and solve the multiplication equation to find how many hours the balloon traveled if it covered a distance of 70 miles. Now, don't forget, remember that word per means each and every time. So if I see 10 miles per hour, we want to use the variable h. We are asked to write and solve an equation. Well, that's not really what we want to do. What do we want to find? Find how many hours. That's why I would say, okay, let h be the number of hours that balloon has traveled. Now I could sit here and add h and another h and another h, or I should say 10 and another 10 and another 10. But the question is, how many tens? How do we write that as a multiplication equation? Well, each of those h hours would be 10 miles. You may write the dot, usually I don't. So 10h equals 70. I bet, folks, that you can solve that just fine. So I just wanted to show you how to set up in a multiplication equation. Let's do one more, or a few more. Here I'd go ahead and ask you to pause the video and find which equation will match each situation. So for this one, we got $7 each and every hour. Oh, per hour, $7 per hour. Which one says 7x? There we go. 7x is equal to 21 would be the appropriate equation there. Jupiter has 18 moons. This is 2 times more than Neptune. Okay, wait a second. So n is the number of Neptune, and we have 2 times that. So the equation that would match up here, 18 is equal to 2x's. Lastly, distance between Little Rock and Benton is 24 miles. That is triple. Aha, what does triple mean? Triple means 3 times. Distance between Little Rock and Maumelle. 3 times that distance. Looks like that fellow. So now you guys know how to solve and write one-step equations involving multiplication. Don't forget, folks, when you do this work, you're writing the directions down, and then problem, work, answer, and check. We've really been working on that. If you have a word problem, you do not need to write the entire word problem. So in that case, you would simply make sure you got the directions still, but write the work and the answer and the check. Although sometimes you're actually going to have to say, oh, 2 times x equals 10. That's the problem. But you do not need to write the entire word problem down. All right, folks, let me know if I can help you. Do well, and we'll see you soon.